There are more than 150 species of ducks, geese, and swans, whose wingspans range from a foot and a half to just under 7 feet. Compared to most other birds, their heads are large, their necks are long, and their tails are short. The bills of these birds are usually blunt and wide. Ducks, geese, and swans possess waterproof feathers and a thick layer of down for insulation. These birds are unusual in that they molt their flight feathers all at once, since most birds gradually replace their flight feathers. This sudden molting leaves them flightless for a period of 3 weeks to a month during the time when the young are still fledglings. The down which covers the young insulates them and makes them more buoyant. Most ducks make concealed nests on the ground, near water, but some, such as wood ducks, mergansers, buffleheads, and goldeneyes, nest in tree cavities. Ground nesting species typically suffer greater predation on their young than tree nesting species.
Females are more likely to mate only with males which perform the...
Frogs can be very vocal, and some frog songs can be heard for more than a kilometer. Male calls not only attract females, they also announce a male's territory to rival males. Frogs can make other sounds as well, such as release calls and distress calls. Vibrations of the vocal cords produce sound, usually during exhalation. There is no evidence of female preference for different songs. Larger males may produce deeper pitched songs, for example. The larger males simply establish a larger territory. Some frogs breed in certain seasons of the year, others whenever proper conditions occur, such as rain, and others can breed over a prolonged time.
Natural selection would favor this if there would be genetic consequences of, say, reduced offspring viability when members of a population outcross with other populations.
Males of the hooded warbler can be recognized for the distinctive black hood.
One significant genetic differences have accumulated between two populations, difficulty in such as chromosomal
because of these chromosomal differences, their hybrid
number,
offspring
or in
might be
chromosome
less
structure,
viable,
such
less
as
fertile,
translocations and
etc.
inversion.
This
It
sometimes
becomes increasingly
is the changing
unlikely
of the number
that
of
hybridization
chromosomes where
between these two
a group may have an extra chromosome
will
or
produce
two. This is
healthy,
known as a new
fertile offspring.
Sometimes whole extra
If that
sets
is the case,
of chromosomes can be
individuals
added.
of
This is
each
known as
population
polyploidy.
are better
Sometimes a
served
region of a chromosome
mating within
is
their
excised
population
and reinserted
rather
at 180
than
degree
hybridizing
angles, in other words,
between
upside down.
populations.
This is an
Since
inversion.
their offspring would be less
Sometimes a
likely
piece
to
of one
survive,
chromosome
and all of the
breaks
energy
off
that
and
they
is attached
exerted
to a
in
different
defending a
non-homologous
territory,
chromosome.
or in
This is known as a
producing eggs,
translocation.
or in caring for
And
their
so
young,
these
all of this
chromosomal
would
differences
essentially be
often
wasted
separate
because their
populations
offspring
because
might
populations
die
which attempt to
or at least be
interbreed
less
when they have
likely to
chromosomal
survive.
differences would be at
So,
a disadvantage given
natural
that much of
selection
their reproductive
often
effort
favors
might be wasted.
isolating mechanisms. There are different paces at which evolutionary change can occur.
From an ancestral
Gradualism
population
depicts
the natural
scenarios
selection
in
could
which
act
evolutionary
on
change
one of
occurs
these
slowly
species so that
through
they
gradual
adapt
transition.
to a specific
Take, for
habitat,
example,
say swamps,
the evolutionary
while
changes
natural
seen
selection
in the horse
could act
lineage. The
on
changes
a
which
different
transform the
species so
small,
that they adapt to, say,
multi-toed,
deep woods
ancestral browsing
environments.
organisms
And so
into
thus,
the large,
speciation
grazing,
helps contribute to
single-toed horses
adaptive
of today
variation so
occurred
that
gradually
one
over
more
tens of millions of
generalized
years
phenotype,
as
there
ancestral
may be
populations slowly
very
adapted
specific
to the
phenotypes
spread of
adapted to
grasslands
very
throughout the world
specific
and a number of
environments.
climatic changes.
Sometimes
In
evolutionary
contrast,
change
some
occurs
evolutionary
gradually
changes can
over
occur
long
very
periods of
quickly.
time. as
Evolution can
changes
occur in
are very
fits and
slowly
starts,
accumulated.
where
This is known as
changes and new
gradualism.
species and new traits
In other
occur in a short
cases,
period
there
of
may
time.
be a
This may
time
occur
where
because
evolutionary
of
change
polyploidy,
occurs
a scenario
in a very
in which
short
evolutionary
period of
change
time.
is not gradual,
Maybe there's a
but
mass
occurs in an
extinction,
instant as new
and so in
chromosomal
the
sets
aftermath
are
of a
added.
mass extinction,
This sometimes
when one's
occurs
predators
after
are
a mass
gone,
extinction,
there are new
so
ecological
that
niches,
following
and
a major
adaptation
change
occurs
throughout the
rather
world,
quickly.
there are new
Or
environments
perhaps
new
one
niches to
genetic
which
change
ancestral
which occurs in
populations
one
can
generation
adapt very quickly.
that would affect
And so,
polyploidy
evolutionary
with a whole
change
extra set
in
of
some
chromosomes,
periods occurs
or
very
which would
slowly.
affect, say, flower
This is
blooming
gradualism.
time.
And in
This would
other
create
instances known
a
as
new
punctuated
species in
equilibrium,
one generation
there can
and
be
not
a
through
period of
gradual
stasis
change.
followed by
This is
rapid
known as
evolutionary
punctuated
change.
equilibrium.